Welcome to the DIY Honda Garage channel. In this presentation, we will troubleshoot DTC P1454, which represents an issue with the FTP sensor, fuel tank pressure sensor, circuit indicating a range or performance problem in the Honda Odyssey models from 2011 to 2017. This specific diagnostic trouble code concerns the functionality of the FTP sensor, which plays a vital role in monitoring the pressure within the fuel tank for proper emissions control. A well-functioning FTP sensor is essential for the engine control module, ECM, to make accurate fuel mixture adjustments that minimize emissions. Not only can this affect vehicle performance, but it also influences compliance with environmental regulations. We will explore the troubleshooting steps required to diagnose and repair this issue effectively, referencing the necessary components and system operations involved. Identifying the precise causes and symptoms associated with this error will also guide us in ensuring a successful fix. DTC P1454 indicates an FTP sensor circuit range or performance problem. The FTP sensor is located near the fuel tank and measures the pressure within it, ensuring that the fuel system operates efficiently. This measurement is crucial for the engine control module's performance calculations to maintain optimal combustion and emissions levels. A malfunction in this sensor can lead to incorrect readings, triggering the DTC. DTC P2422 indicates an issue with the EVAP canister vent shut valve, which regulates the flow of vapors from the fuel tank to the atmosphere. A stuck closed malfunction in this valve can create pressure imbalances and trigger warning codes as well. Both codes signal potential inefficiencies in the fuel system that could negatively impact vehicle emissions and performance. The onboard diagnostics (OBD) system constantly monitors these components to ensure compliance with engineering standards. The possible causes for DTC P1454 primarily include a faulty FTP sensor that fails to provide accurate pressure readings. Additionally, wiring issues can hinder signal transmission from the sensor to the engine control unit, leading to erroneous diagnostic codes. Furthermore, a malfunctioning EVAP canister vent shut valve can also contribute to this error by obstructing the normal pressure release and vapor flow. Environmental conditions, short circuits, or degradation in electrical components over time may also adversely affect sensor performance. Therefore, it is critical to examine both the sensor and its associated wiring harness thoroughly for damage or disconnections. Conversely, for DTC P2422, blockage or stuck mechanisms within the vent shut valve could trigger the system's alert, making it a key area of focus during diagnostics. When dealing with DTC P1454 and P2422, several symptoms may manifest in your Honda Odyssey. The most common indicator is the illumination of the check engine light, alerting the driver to potential issues within the emission system. Additionally, poor engine performance may occur as a result of these sensor malfunctions, potentially leading to rough idling or decreased acceleration. Increased fuel consumption is another logical symptom, as the engine control module may misjudge fuel requirements without accurate pressure readings from the FTP sensor. Furthermore, you may experience unusual sounds from the fuel system or noticeable drops in fuel efficiency. Ultimately, these symptoms together signify the necessity for immediate diagnostics to prevent further engine damage or regulatory violations. The first step in troubleshooting DTC P1454 involves turning the ignition switch to the on position, which activates the vehicle's electrical systems without starting the engine. At this point, it is crucial to use the Honda Diagnostic System HDS to clear any existing diagnostic trouble codes stored in the system. Clearing the DTC is vital for ensuring that any new data acquired is not influenced by outdated information. After clearing the DTC, turn the ignition back to the lock position to reset the systems. This initial sequence lays the groundwork for accurate diagnostics, ensuring that the HDS can effectively capture a new, clean state of the vehicle's performance data. In the second troubleshooting step, the focus is on the fuel system's pressure integrity. Begin by removing the fuel fill cap, which allows any residual pressure to vent from the fuel tank. This step is significant, as it serves to relieve any possible pressure clogs that could be contributing to the FTP sensor's performance issue. After removing the cap, the technician should wait for about 1 minute. Allowing this time aids in normalizing the pressure within the fuel system. Following this period, the technician must turn the ignition switch back to the on position again, re-engaging the electrical systems and preparing the diagnostic systems for the next checks. Now comes a critical diagnostic check utilizing the HDS. At this step, the FTP sensor's function is evaluated in the data list. The mechanic should look for a value between -0.67 and 0.67 kilopascals, which equates to -0.2 and 0.2 in Hg, or any output between 2.4 and 2.6 volts. Achieving results within these ranges indicates that the FTP sensor is operating correctly and providing accurate readings to the engine control module. If the readings fall within the acceptable range, then the troubleshooting proceeds to the next step. Conversely, if the readings are outside of the specified ranges, further investigation into potential faults must be conducted to narrow down the issues affecting the FTP sensor's performance. After confirming that the FTP sensor is functioning within its expected parameters, the next step requires reinstalling the fuel fill cap. Proper closure of the cap ensures that the fuel system can maintain its pressure effectively, crucial for the sensor's optimal performance. Once the cap is resecured, clear the DTC again using the HDS to reset the system's understanding of the current state. Following this, start the engine and allow it to reach an elevated speed of 3,000 revolutions per minute, RPM, without load to increase engine bay temperatures and activate the radiator fan. Keeping the engine at this speed will also create the right conditions for the emissions control system to function optimally, allowing for comprehensive diagnostics during the next monitoring phase. This step focuses on monitoring the onboard diagnostics (OBD) status using the HDS after running the engine at a constant speed. It is crucial to check whether the HDS indicates any codes, specifically DTC P1454 and/or DTC P2422. If the status shows failed, it signifies that there are persistent issues associated with the FTP sensor or the EVAP canister vent shut valve. The technician will need to pursue additional troubleshooting steps to isolate the failures. However, if the HDS indicates passed, this suggests that the system is functioning correctly at that moment, although intermittent issues could still exist. In such cases, it is advisable to inspect wiring connections or possible obstructions in the fuel system components to ensure reliable, long-term operation. With the DTC status verified, the next troubleshooting step is to clear the DTC one more time using the HDS, resetting any stored issues again. After this, turn the ignition switch back to the lock position to ensure all systems reset before further assessment. Subsequently, the technician will remove the EVAP canister vent shut valve from the EVAP canister. This step is important as it allows access for testing the actual mechanical operation of the vent shut valve and its electrical connections. ensuring that the valve is functioning correctly and not contributing to any blockage or malfunction that would trigger the DTC codes. By focusing on these specific components, the technician can narrow down the causes of the issues and ensure any faulty parts are replaced. In the final step of this troubleshooting process, the technician will connect the 2-pin 2P connector back to the EVAP canister vent shut valve, which enables electrical communication for testing. Following this connection, the ignition switch should again be turned to the on position, which will activate the electrical systems without starting the engine. The next critical action is to select EVAP CVS on in the inspection menu of the HDS, initiating the system's self-test for the EVAP canister vent shut valve. This verifies whether the valve performs correctly when commanded by the engine control module. Successful operation during this step confirms that the complete EVAP system is functioning as intended, allowing for accurate pressure monitoring and venting, ultimately preventing potential future DTC codes. After completing all previous troubleshooting steps, the final verification is crucial to confirm that the repairs have resolved the original issues. This means checking if all components, including the FTP sensor and the EVAP canister vent shut valve, are functioning correctly. Following any repairs made, clear the DTCs once more using the HDS, ensuring that the system starts fresh without stored faults. A test drive of the vehicle is then recommended to see if the check engine light reappears during normal operating conditions. Observing that the vehicle operates smoothly without errors in the OBD system solidifies the successful repair and confirms that no further issues remain. Always document any changes made during this final verification to maintain thorough service records. To prevent future occurrences of DTC P1454 and P2422 in your Honda Odyssey, routine maintenance is essential. Regular inspections of the EVAP system and its components can help identify potential issues before they escalate into significant problems. One important task includes routinely checking the fuel cap seal for signs of wear or damage, as a poor seal can lead to pressure inconsistencies, prompting codes. Furthermore, ensuring that sensors, including the FTP sensor, are functioning optimally through periodic checks can help prevent malfunctions. When performing maintenance, it is also advisable to replace any visibly corroded or worn-out electrical connections, thereby enhancing the vehicle's overall electrical integrity. Adopting these preventive measures assists in ensuring long-term operational efficiency and compliance with emission standards. In conclusion, effectively troubleshooting DTC P1454 and P2422 requires a thorough understanding of the roles of the FTP sensor and the EVAP canister vent shut valve. Recognizing their functions and the specifics of how they interact within the vehicle's emission control system is crucial for reliable diagnostics. Regular monitoring and maintenance are imperative to mitigate the chances of encountering these DTCs again. Prompt diagnostics are essential for identifying problems early on, allowing for timely repairs that can prevent further damage or violation of emission standards. Ultimately, being proactive through maintenance schedules ensures that the Honda Odyssey maintains optimal performance, ensuring both efficiency and compliance. Please like and subscribe to the channel. See you next time.